Today we'll be doing a very important topic, that is Gauss law. First of all, we'll understand what is electric flux. The definition for electric flux is the number of electric field lines crossing a unit area is known as electric flux. The formula for electric flux is E dot A. This is the symbol for electric flux. It is a scalar quantity and the unit is Newton meter square per coulomb or Vm. We can also write phi as integration of E dot d, that is the area. Now the derivation of Gauss law. States that electric flux that we have studied earlier, I've written the symbol electric flux through a closed body is equal to 1 upon E naught times the charge enclosed by the body. The charge enclosed. So, phi is equals to 1 upon E naught Q enclosed. That is the charged enclosed. Is equals to Q by E naught. The flux is equals to E dot ds, which is equals to Q by E naught. So further we'll prove this theorem. So the proof for Gauss law. So we'll consider a charge Q. Inside a Gaussian surface. Gaussian surface is a closed surface, which is a sphere of radius r. So this is the charge Q. It's enclosed in a spherical surface, and this is the radius. We'll find the electric flux at this point. So the electric field is in this direction and the unit vector is in this direction. So we know that E dot ds, integration of E dot ds can be written as E ds cos theta, as A dot b can be written as A b cos theta, the dot product. So E ds cos 0. As we can see, the angle here is 0, which is equals to E dot EDS into 1. Cos theta is equals to 1. And we know the electric field is constant. So EDS. The electric field is equals to Q upon 4 pi epsilon naught R square into ds. We'll integrate ds, so we'll get S So the surface area is 4 pi I r square. We know the electric field is Q upon AE. So we'll cancel these out, which gives us the answer, the proof. E dot ds is equals to Q by epsilon naught. The charge enclosed and epsilon naught. So this is the proof for Gauss' law. So this is how we proved Gauss' law. That is this. Thank you, and I'll see you in the next video.